All right, welcome to the Explainer. Today we're going to break down the paper that basically taught computers how to find faces and to do it instantly. It's a really cool story about how a few simple but totally brilliant ideas solved a problem that seemed just impossibly complex at the time.
So let's start with something you see all the time, right? Those little boxes that just pop up around faces whenever you take a picture. It happens so fast, we don't even give it a second thought. But have you ever really stopped to wonder how a machine, which just sees a grid of pixels, pulls that off in literally the blink of an eye?
Okay, now here's what makes this story really amazing. The blueprint for all this stuff was actually laid out more than 2 decades ago. I want you to try and remember what computers were like back in 2001. We're talking about like a 700 megahertz Pentium 3 processor. That's a machine that is hundreds, maybe even thousands of times slower than the phone you've got in your pocket right now. And that was the hardware they were working with.
So in 2001, these two researchers, Paul Viola and Michael Jones, published this paper that just completely cracked the code. And you can see it right there in their own words. Their goal wasn't just to be accurate, it was to be extremely rapid. They wanted to make real-time face detection something you could actually do.
You know, their solution wasn't some single magic bullet. It was actually a combination of 3 really brilliant interconnected ideas. First, they came up with a super fast way to find patterns in an image. Then, they figured out a smart way to pick only the patterns that actually mattered. And finally, and this is the genius part, they built a system to avoid wasting any time on parts of the picture that are obviously not a face. So, let's break down how they pulled it off.
Okay, first up, the biggest hurdle they had to get over was speed. I mean, to find a face, you have to look for all these basic patterns, like edges and lines, all over the place, and at all different sizes. Doing that pixel by pixel is just painfully slow. They needed a major shortcut.
So they used these simple little templates called HAR-like features. The easiest way to think of them is just as little patterns of black and white boxes. The computer slides these patterns all over the image and just measures the difference in brightness. And it makes perfect sense, right? On a human face, the eye region is pretty much always darker than the cheeks right below it. That's a perfect pattern for one of these features to spot.
But of course, there's a catch. And it's a big one. For even a teeny tiny 24 by 24 pixel window, which was the basic size they were looking for, there are more than 180,000 possible features to check. Trying to calculate every single one of those would just bring any computer from 2001 to its knees.
And this is where their first big idea comes into play, the integral image. Honestly, the best way to think about it is like a pre-computed cheat sheet for the picture. Instead of adding up pixels over and over and over again, they created this map that lets you get the sum of pixels inside any rectangle, almost instantly.
So here's how it works, and it's actually pretty simple. You do one quick pass over the image to create this map. After that, you can find the total pixel value inside any rectangle you want, doesn't matter how big or small, with just 4 little lookups on your cheat sheet. That's it. This one trick made calculating features ridiculously fast.
All right, so that brings us to the next problem. We can now calculate any of our 180,000 features in a flash. But which ones are actually useful? Which ones are good at telling a face from, say, a bookshelf? The truth is, most of them are totally useless.
For this part, they used the machine learning algorithm called AdaBoost. I love this analogy. Think of AdaBoost as a super efficient casting director. It basically holds an audition for all 180,000 of those features. And through this clever process of trial and error, it picks out a small team of all-stars, the absolute best features for the job. And what it found is so cool, because it's so intuitive. The very first feature AdaBoost picked was the one that looks for the eye region being darker than the cheeks. The second one it picked checks if the eyes are darker than the bridge of the nose. I mean, the algorithm figured out these really basic fundamental properties of a face all on its own.
Okay, so we've got super fast features, and we've picked out the best ones. But even with a smaller set of features, checking them across every single part of an image, at every size, well, it's still way too slow. And that leads us to their third and maybe their most clever idea of all.
They built what they called a cascade. You can think of it like a series of security checkpoints. Instead of blasting every little window of the image with the full complicated detector, they start with one that's just ridiculously simple. And if a window can't even pass that first easy test, it gets thrown out immediately. No more time wasted on it.
And that first checkpoint is unbelievably efficient. It uses just 2 of those hair-like features. And with just those 2, it can instantly throw out about 40% of the things it looks at that are clearly not a face. Like a blank wall or a patch of grass, gone. So the windows that do pass the first easy stage then move on to a slightly tougher second stage, and then a third and a fourth and so on. Their full detector had 38 of these stages, and each one gets a little more demanding. So only the absolute most promising, most face-like parts of the image ever make it all the way to the end.
And the result of this whole cascade idea is just staggering. Get this. Even though their final detector had over 6,000 features in total, because most of the image gets projected so early on, the system only had to check an average of 10 features per spot. 10. That is the real secret to its incredible speed.
So what do you get when you put these three breakthroughs together? The integral image, the AdaBoost feature selection, and this classifier cascade. Well, you get a revolution. Simple as that.
First, let's talk about accuracy. On the standard tests that everybody used, their system went head-to-head with the best, most complicated systems out there, and it totally held its own. In some cases, it was even better. So the key thing is, they got all this speed without having to sacrifice quality.
But this is the number that changed everything. 15 frames per second. On that old 700 megahertz computer, this wasn't just, a little bit faster. This was the difference between something that works in a lab and something that can be in a real product. This was real time.
So here's the bottom line. The Viola-Jones framework was about 15 times faster than the next best thing out there. It pretty much single-handedly made face detection a practical, usable feature that could be put into everyday electronics, from all those digital cameras in the 2000s right up to the smartphones that we all use today.
The Viola-Jones framework is just such a beautiful example of how really complex problems can sometimes be solved by combining just a few simple, powerful, and, elegant ideas. It's a great reminder that progress isn't always about having more raw power. Sometimes it's about just thinking smarter. And it really makes you wonder, what are the elegant breakthroughs happening right now that are laying the foundation for the AI of tomorrow?